So I'm standing in the middle of an engineering room at a startup in LA. So y'all know, beautiful LA day, not a cloud in the sky. We could feel the ocean breeze coming through the window. I think the CEO actually went surfing that day too. Couldn't be better. Guys, we were in a complete blind panic. Like the site crashes again in front of customers. I walked to the back of the room. I set up this whiteboard that said number of days since last downtime, 0. Oh, God damn it. I erased days and replaced with it hours because you know what? That sign has said 0 for 4 days in a row now. And like I'm trying to increase the morale of the engineering team and celebrate the little wins. And that sign saying 0 4 days in a row, that is not helping things at all. So we don't understand though. We've been working crazy hours. We were living together in a small apartment. I was actually sharing a bedroom with the CEO and the CTO. We're always stressed out. We're always snapping at each other. And we're trying our best, but like, is it really that hard to make like a website? One of the salespeople, she comes running into the room. She says, okay, guys, I understand you're trying your best here, but like I got a call with a client in an hour and they want to put a $100,000 order. Is the site going to be up? We looked at her. We looked at each other. We actually don't know if the site's going to be up in an hour. So don't worry, we ended up fixing that issue that day, but it took the whole day and it took pretty much every engineer, like all 10 of us. So round of applause or emoji reactions or anything we got for anyone who's run into that before. What's the solution though? Well, if we're having bugs, we just need to hire more QA people, maybe? Maybe we just need more people to check the site. We just need to check it better. Well, I'm sure some of you are like in the opposite situation right now. Like you have this QA process that forces you to do no more than one release every 2 weeks at the end of each sprint. And even if you want to do like a small copy change or change the shade of blue, you can't. So you can't merge any code into the QA to sign off on it, which usually takes about a day. Sorry, wait, I forgot. All your QA teams in India, you're in Los Angeles, there's like a 15-hour time zone difference. So you end up waiting at least 2 days. So you end up having to stay at work until midnight to try to do a deployment, only to have a QA person block the release again on something completely unrelated to what you were working on the whole last 2 weeks. And then you're still behind. Okay, so we don't need to hire more QA people, and there's too much work. We probably just need to hire more software engineers. It's probably that simple. So who's trying to do that now? I know David is. That's everything that Superstruct is doing is helping companies hire engineers. Interviewing engineers week over week, hiring 4+ engineers a month, but you're still having more outages and getting less done. And now people are just bumping into each other. So like what's going on here? There must other websites are up. Other people are on cushy jobs. Like how come this seems so hard to do? So I've gone from having things fall apart all around me at that first startup to learning how to ship the new Super Bowl and NFL.com homepages without a hitch, to fumbling into a couple other startups facing the same issues. And now I'm over at Remo. I'm leading the engineering org. And guess what? When I joined here, I saw the exact same issues on the other side of the world as I did when I was in Los Angeles at the first startup. So I've learned you can ship new features on Fridays at 5. Like that's doable. I've done it. You can make a difference without working late or being all stressed out. You have the time right now to do all that proactive work as an engineer. You just need to know what to focus on and what to knock out first. So a good way to explain this is I like to take a page out of the sales and marketing team. So they had this idea of like a sales funnel. So you have almost like an upside down triangle looking like this. And the whole point of sales and marketing is to increase revenue, increase sales. So they're all focused on making the funnel wider at different parts. Well, we can take the same idea, but with the reverse outcome. We can have like a bug funnel. And our goal is to shrink that as much as we can. So what's our funnel look like? Well, first we have static analysis at the top. That's like ESLint TypeScript. Now we have unit tests on the next step, smoke tests after the unit tests, monitoring, and then postmortems. So the earlier the step in the funnel, the more issues we catch. So any organization I go into, I take a look at their current funnel. So do we really need to focus on end-to-end tests when there's so much low-hanging fruit here and there's no TypeScript or ESLint setup? Like, no. Like, let's do the low-hanging fruit stuff first. You can get away with really basic end-to-end tests if you get everything in the right order. And the reason I like this funnel analogy is funnels shrink, but they don't close. Narrowing the gap does get harder and harder over time. But the goal is to keep looking at this funnel and keep attacking the easiest to tackle next step one chunk at a time. Remember, every one of these steps gets you towards the end goal. The end goal isn't perfect end-to-end tests or 100% unit test coverage. The end goal is not having bugs hit the customers. That's the end goal. So we split the testing up into steps because in the real world, you're not going to be able to convince the business or the product or even your engineering manager to just drop everything and write tests for months. There always has to be a balance between this and features. So let's take a look at step one, the static analysis side. So at this point, I've noticed engineers tend to jump right into writing unit tests or end-to-end tests. But there's a low-hanging fruit here with static analysis. Unlike unit tests, these have really little maintenance. So ESLint, it doesn't break or become flaky. Once you have a lint rule turned on, it pretty much works forever. We can chip away, we can use this fact to chip away at this step and to buy us even more proactive time that we can invest on the next steps. So instead of thinking, oh, here's a bug, I really got to write an end-to-end test for this, I really got to write a unit test for this, try to shift your mindset. Like, can I write a lint rule for this? It's surprisingly as simple as writing a unit test, but it runs on every single keystroke in your IDE, and you can catch issues even more quickly that way. A great example of this, I was once working on a project for MapQuest. Yeah, the one where you print out the maps when you were driving to Disneyland with your family. So I had someone on my team who kept forgetting to spell MapQuest with an uppercase Q. So he kept spelling it with a lowercase q instead. Every time I reviewed his code, I catch him doing that. Until finally, one Friday afternoon, I was like, okay, I'm done with this. I sat down and I wrote an ESLint rule that checked every single string, looking for the word MapQuest with a lowercase q and yelling at engineers to make it an uppercase q. Now, it seems like a very small thing, but for the MapQuest brand, this was a big deal. I was able to then publish this as an ESLint rule to our private NPM repo. And not only could my team, who was doing some MapQuest projects, use it, every other team in the company for the rest of history, no matter what code base they're working on, could install it and use it too. Okay, sorry, this is her Dave spoken. So after the linting, we can move on to our next step, which is unit testing. So you might begin to notice, if you nail linting by setting up ESLint and TypeScript, you actually have to write fewer unit tests than if you started looking at the unit tests first. That's on purpose. If we go back to this funnel analogy, we already caught a lot of the bugs up here. So you don't need to write unit tests for things that have already been caught. A good example is if you're using TypeScript with strict mode, you don't need to write a unit test to check if something's null or undefined. It's already caught up here. That's an important thing to remember. And that's why I like focusing on this part first, because now you're saving yourself work here. You're getting the same results for less work. Next, we're moving on to smoke tests. So when you think about smoke tests, I like to think of where this came from. So back in the day, when they were building circuit boards, in the circuit board factory, they just, right before they shipped it, they would plug in the circuit board, see if it smoked, and if it didn't smoke, they'd ship it out the door. So remember, that's it. Plug it in and see if it smokes. Don't overcomplicate it. So the core issue with starting with smoke tests is that you're having all these bugs fall in near the top of the funnel, and they're landing on the smoke test step. So every time I go into an organization, this happened at System 1, this happened at Remo, they'd always say, James, I really need your help to set up more stable smoke tests. But by nailing the static analysis and the unit tests first, we actually got away with really simple smoke tests. So a great example of this was while at System 1, I was working on a publishing project. And we had some complicated smoke test suite set up, and it worked like 50, 60% of the time, and we'd skip tests here and there. But after setting up the static analysis and more unit testing, I realized we could get away with just making a smoke test that checked if the ads load. And having that one test run consistently caught 80% of the problems that could have fallen through. That's why I really stress like nailing the first two steps first. So we've done all the testing we could. Our new feature's out in the wild. So there's still one more place to catch an issue before the customer sees it. And that's with monitoring. Now, there's a million tools out there like Datadog, Sentry, Bugsnag, whatever. They're all really similar in functionality, so it doesn't really matter which one you use. The important part is to set something up and at a bare minimum, have it report all uncaught errors. Once you have those cleaned up, you can start thinking about adding custom metrics to monitor. Great example is at Remo, we monitor the number of times users refresh the page for two reasons. One, we found that it's a great proxy metric to see if people are having mic cam issues. And two, we just had a lot of customers complaining that they had to refresh the page. And so we wanted to make sure we had it under control. Now, whenever there's a spike in refreshes after a release, we can quickly look into the code, see if there's been any changes on mic and cam code, and revert it. So once you have the alerts set up, that's all fine and dandy. But who's responsible for when they go off? You might want to say everyone, but when everyone is responsible for something, no one is responsible for something. Diffusion of responsibility kicks in. So that's where setting up a tool like Ops Genie or PagerDuty or some sort of on-call management tool is really handy. Because at that point, you can schedule out the important but unplanned reactive work. You can tell an engineer every week, you're responsible to react to everything. You are the shield for the rest of the engineering organization. And this is a good example of being able to plan unplanned work, being able to expect the unexpected. You know things are going to keep crashing every day in the short term, so just make it clear who's responsible to shield it. And from there, having each person rotate also solves the problem of, I like to call it the Captain America problem. So if you're familiar with Marvel Cinematic Universe, the way Captain America got frozen in the first place was he crash landed like a plane or a spaceship into the ice. And there's a scene in the Avengers where Iron Man tells Captain America, why don't you just eject? Why didn't you just eject and parachute out? You didn't need to be in the plane and crash land. This happens a lot on the engineering side too. You'll find some people in the engineering org, especially the earlier engineers, they like try to save the day every single time. What ends up happening is now you have people on the team who aren't familiar with the code, so they can't actually help on this on-call process. And then the original engineer either gets burned out and leaves, or just isn't able to work on new features. This scheduling out the on-call helps prevent that and makes it clear that everyone on the team's responsible, but they're responsible for it 1 week at a time. After the monitoring side, you'll still have production issues. And that's where the postmortem comes in place. Now, this is really important because this isn't really a technical thing. Like, you don't use machine learning to fix this. This is more of a culture thing. Now, the important part here is when a production issue happens, I like to make sure the engineering team takes responsibility quickly and in writing. So a production issue happens, a business disruption ticket is made in Jira, and then in that ticket, we write out what happened, what the short-term fix was, what potential medium-term fix was, and what impact happened to the business. Now, we make sure we don't blame anyone here, because if you get stuck up in that blame culture, what's happening is people are just going to start sweeping stuff under the rug, and you'll just have more and more and more issues. I promise. So during this on-call meeting, we like to kind of figure out exactly what the business impact was. If your company doesn't have a way to tie a feature to revenue, maybe you can tie it to like an NPS score. Maybe you can tie it to the App Store rating in the App Store. And if you can't figure out what to tie it to, maybe the takeaway was to calm down. Like, that's also a really valid takeaway too. So all in all, we have static analysis, unit tests, smoke tests, monitoring, and postmortems. Looking back at the last 2.5, 3 years while I was at System 1 and continuing on to Remo, this like long-term realistic expectation setting, people first thinking is what really set me apart. So I became an accidental leader of the team at System 1 because I was prioritizing proactive work against this reactive work. Not because like I had a PhD in computer science or because I wrote some crazy machine learning library from scratch. Navigating proactive work is not only what got like me ahead career-wise, but also my entire team. And doing non-urgent but important work reduced everyone's stress level and solidified relationships with colleagues I still lean on to this day. In other words, investing the time on this and figuring out how to crack this is worth it. Deploying on Fridays is great. Spending time working on cool new features rather than fighting fires every day is a blast. And getting buy-in from stakeholders by pitching these like small changes instead of constantly being ignored is a breath of fresh air. So you already have the time to do proactive work as an engineer. You just got to nail each part of the funnel first. So thanks everyone for your time. My name is James Hush. If you want to learn more about like making stuff that doesn't break, I'll be available starting in July for any sort of talks or workshops or anything like that. I'm launching a new website in a couple of weeks with some more information on that side. But if you're curious, feel free to send me an email at hello@jameshush.com or hit me up on LinkedIn.